Um, David, if you see anyone coming in and entering into the meeting, please, if you would allow them in, act and have access. But I
Sure.
just wanted to start off the meeting to say hi to everybody. And I know everyone probably knows who I am or has worked with me in the past. Well, I've been doing this for about 20 years now. And as I was mentioning earlier, is that AutoStamped is a group of manufacturers that we directly deal with that automate the process of tool and die. And for those who are stampers or die makers, I feel that we have niched ourselves in providing shortcuts in this industry to help the profitability of companies. And with that said, we brought on last week in our last webinar tool planners. And Tool Planners was able to show us ways of costing out their tooling and the relationships that they have now with Hexagon and under the FTI products, and they have relationships with Cimatron. They're really moving forward as far as being the leader in industry for costing, and it's those methods are being used in Toyota, Honda, Ford, Toyota, Mercedes, and ultimately, we come to this week, and I want to introduce Dave Lindemann. He's from Cimatron, and Dave is going to give us a presentation of how the industry has changed now and automated the ways that we can design tooling process. And um, and of course, if there's any questions along the way, I think what we're going to do is allow Dave to go through his presentation, and at the end, we'll again, like last week, we'll open this up for any questions and answers. I do ask just for any type of house cleaning rules. If we can mute our lines, this will just help us um, you know, talk a little bit about the information at hand. And of course, with that said, without further ado, I'm going to turn this over to David Linderman, and maybe you can tell us a little bit about yourself and what we're going to see today.
Sure.
Thanks, everybody.
Yeah. Can everybody see the screen okay? You should see the webinar PowerPoint.
Dave, we
So,
see everything perfectly.
okay. So I'll
Thank you.
just jump through a few things here.
Sure.
So, just a little bit about Cimatron. We specialize in software for the application of molds and dies and advanced cam. So, from 2.5 axis and drilling, we'll go all the way up to 5 axis continuous. Very comprehensive CAD system since it's been around since 1982. Very strong NC package as well. So you can see that we've really focused on the tooling industry for everything, and it makes a difference when you talk to us because you're talking to someone who's been a tool maker, or if you call tech support, they know what the problem is that you're running into. And the terminology inside the system too, that helps greatly to understand what you're doing. So you're not looking for a CAD function, you're looking for an operation that you would actually perform working on a tool. So a little bit about the die, just to get into some more specific details. We have specific applications to help find costs, whether type of die it is. We do analysis based on forming abilities using an FEA analysis, specific tools dedicated to creating operations within the die design. You can then optimize all this and lay it all out into a strip quickly. Again, we can check on the spring back, and then we can use that information to compensate on the tool at that particular station. We have dedicated die sets and die components, so you're not looking for something that's abstract, a pin, but you're looking for the specific pin that you would order from Dayton or Danley or whatever your supplier is, and then knowledge of what that hole is that pin sits in. That information then gets handed on down to our NC, and we can automate the drilling then. Then specific tools for checking for collision, handling engineering changes, taking measurements, and that all gets translated over to into creating drawings quickly so that you've lay out the form of your drawing. You just repeat that form and everything can be updated with the correct dimensions. Since it's all tied together, if something changes in the design, you get flagged that there's something that needs to be updated in a drawing or something needs to be updated in the NC. So you can check to see, what's your actual progress so far and determine if you want to go ahead with that, or if you need to scrap the what you've done so far, if you can continue with it. So just a few specifics. We're going to look at forming, nesting, some things to do with the die sets and the components, and then just at the end, just a little bit with the motion analysis, just so you can see it.
Before we
Oh,
begin, if I just may say that, David and everybody, this is the same part we used last week. We're going to continue the thought process of taking it from estimation to design to prove out to manufacturing. So you will see this part for those who come for the next 4 weeks. So with that said, sorry about that, Dave. I just want to kind of throw that out there.
oh, no problem.
Thank you.
Okay. All right. So just a little bit about what you're seeing. This is the interface. You can see on the left that there is the history, the tree, all the different elements that are going to go into building the strip or the tool. Then on the right, you have our guide. So it's just a matter of picking on the guide. Let me do that again. Sorry. And then whatever your operation is, it's just a matter of stepping your way down the guide. So this particular part, it's just got two flanges on the outside. We've got that form in the middle, stretch form, and then it's also got like a trench down the middle. So pretty simple brace. I've just copied it over in a sense of kind of laying out in my mind what I need to do with it and understand the part better. So I'm going to make the decision at this point to work off the die side of the part. Doesn't matter which side I choose. I just have my thing set up for the die side. It's measured for me that that part is 3 mil thick, and then it's put that information here in my setup. So setup is kind of like the Bible where we keep our knowledge of what's happening. Here I assign the material, and you can see there's a tremendous amount of materials already in the library. If need be, we can always create another one. So it's not so hard. It's just knowing the properties. But all the formulas here for the K factor, that's included. Any of the rules I want to establish when setting up my die, like my clearances around the punch, also what type of punch we can work with. Do I want that to be a straight land punch with tapered relief or, any of these options you see here. So that's my default go-to value here every time that it encounters the need to create a punch or a punch hole. These are the factors that it will use. Okay. So I've got that setup pretty well established. I'm going to move along. And I'm kind of still just thinking, what do I need to do here? So I'm going to go ahead and run a blank. And it's just a matter of picking the part, knows the material, it takes care of the blank for me. And I let it run here real time so you can see, what's involved here. The calculation is, of course, based on thickness, based upon material properties, and it gives me my outer perimeter pretty quickly. If you want to catch what that length is, it's 861 millimeters. Maybe I need that number to quote the laser cut. Also, I can use it now to see what a crash form would look like. So it gives me an idea of the strains that are involved. It will also take a look at situations where I'm dealing with the safety zones. That could be areas that are potentially going to wrinkle, like the blue you see here. If it's red, I know it's probably going to tear. So all this is helping me understand what do I need to do in order to form the part correctly. Maybe if that's going to wrinkle, I need to find a way to stretch that out a little bit. So here I've got my blank. I can use that, establishing my quote. I'm going to go ahead now and just come up with a few forms. So maybe instead of, thinking about this in terms of one hit, I'm going to think about this more like a progressive unfolding. So to do that, I'm going to do again just a copy over here. It says forming progression. That hasn't really yet established the progression I'll use in my strip, my actual strip, because I want to take a good close look at that when I do that, because I want to use my net utilization. But it's just giving me like a notebook area where I can work with to figure out how I'm going to unfold it. I see the outer flanges. I need to bring those to uh, toward the blank. So I'm just going to pick these surfaces to unfold to. I'm using the little paintbrush tool just to kind of swipe my way down through there instead of, multi-picking all those different little faces. So that's what I'm going to develop out to. And then I pick the flange. It knows the material side. It knows the material. And I just say, go do it. So here it's using the mesh then to create, or the FEA analysis to create what that unfold would look like. And at any step now, I can do the analysis and look at it and say, okay, if I just do this one flange, is it going to wrinkle? Is it going to tear? Do that again to the other side. So again, we'll grab the paintbrush. Just a way to show you that there's simple tools here to do the common things that we might take for granted. Even the mouse itself. Here you'll see me picking on things. I'm not running over to the left side of the screen where the feature guide is to pick all those different icons. All I do is just middle mouse. It moves on to the next option. I pick the option, middle mouse, and then when I'm done, right click. There's the green check mark I need to execute. So we call that saving mouse miles. And you'll notice little things or specialized tools to speed up the process of working through design as you go through this. And as I build this up, I can be naming these the different stations that I'm going to work with. I may, develop out one area and then later on say, well, I really don't need a separate station just for this one feature, and then skip it when I place it within the strip. So it's up to me what direction I want to go. So I'm just picking these faces and saying, I don't want that form. Let's undo it. Maybe that would be its own separate station where I push that form into it, something to stretch out the middle. All right. Moving on to the next one, and now I've got the inside of that groove or trench, whatever you want to call it, to work with. So let's work with that next. And you can see just moving down the line. Let's make sure that I've got that little tail where it's connected. I want to leave that out of the form for now, but we're going to again do a blanking operation, I guess is better to say, where I'm just pushing the shape of these faces down onto other faces. Take the middle and let's do the left side first. There's a lot of different decisions you may run into while you're working this through, and you want to check those each step of the way. This enables you to do that. It might be that, if you're doing a quick quote, you may decide not to go through all these steps, but you can jump right into the strip and say, I've got my blank. I need 10 stations. Let me lay out the nesting so I get my overall strip length and width and go that route. What's nice is that you're not forced into any set way of doing things. You can skip back and forth. I can lay out a rough strip without all the forms I need, and then get a die set around it quickly just to see what my overall size is and start determining the press that I'll need to work in. All that again, it's not forcing you to follow a rigid routine. So now I've got what you basically call a curve blank. It's got the shape and contour of it. And we'll go ahead and flatten that now. And again, so many different tools for doing regular bending, like 90-degree bends where I need to maybe overbend. Maybe with that 90-degree bend, I'm going to crush the radius just a bit to take out some of the spring back. And again, you can check as you go with each of these what the result will look like. So there's the last one. There's my flattened blank for now. And what I might choose to do, looking at my rundown of different things, I can compare the first blank I did to that last blank just to see, if it's basically the same or not. And it is. with just more degree of accuracy since I took each of those steps through. Now we're looking at nesting. As we do this, we want to keep track of our scrap area, our utilization. Is it going to be a one row? Is it going to be a two row? If it's a two row, do I rotate it? Yeah, you can see I'm looking at different options to understand what I like. Maybe I want to shift it down, kind of alternate it or stagger it. What does it look like with width down the middle for the carrier? Then I'm widening it out to have a little more room for the punches. And finally, I'm looking at saying, oh, just give me a one row and let's open up the progression just a bit so I can get, over 60, 63, 64% utilization. Now I'm looking at the dimensions involved in the strip. How many different stations do I want? Am I going to design it left to right, right to left? The first stations are going to be where I do my punching, and then I'm thinking forming after that. Again, no set rule on what you do. It all is dependent upon what you need to do. So here I'm thinking maybe a carrier on the top and bottom, and I'm going to leave the top with more room because I need to put an expanded web in there. Here I can sketch out what I want for this particular carrier to look like, or I can do what I'm doing here, which is have a saved preset catalog of different types of carriers. That way I'm not always sketching it out. Just put it in. I can alter the dimensions as I need to accommodate what that progression really is. So I've got my two carriers in. Let's go ahead and put a web in here. And these, again, whatever I design them up to be, save it. And now I can just position them in as I see where I need to fit them. And you notice I saved myself a little time because in the first sketch of the carrier, I have anchor points, or I can drop that web in. So pretty quickly, I can get a good idea of what's involved. Going a little further, I need to break up this section into a few punches. And I'm not going to worry about everything being perfectly lined up here at this point. I can do that if I want, fully dimension it. And I'm not going to worry about the sketch being perfectly clean either. What I really want to do is just pick an area and say, that's a punch, make a punch. So we'll start doing the punches by hitting the different pilots. So there would be my first punch, and you can see creates a green face at that punch location and then carries it down the strip as it punches all the holes. Here I've got a bit more complicated punch. So definitely I'm going to wire EDM this one. All I do is pick in the center of that area and it gives me the overall perimeter. Tweak this a bit by rounding the corners along the carrier. And then in the middle, I've got this area where it's going to overlap onto another punch. So we'll put what we call a cookie. That overlap can be as I've drawn it, or it could simply be, something with an extra shear so that I'm not, or a gap, I guess, an overlap with that off misplacement so that I can put something in there to avoid the shear that it might run into. And I'm just putting these in now as they make sense to me. So I like to keep things centered if I can for the different, the pressure. Again, pick where I want to start. Doesn't have to be where I drew it. And then it puts the punch in. You can see it carries the hole down the line. So pretty quickly, if I need to develop something for the customer, I can, or I can go ahead and use these things I'm creating for my design, whatever it sees fit to do. Because a lot of times, there's so little time to quote things, and we're quoting hundreds of jobs just to get one or two. So the demands are enormous on finding information quickly. We'll take this shape and punch it now. You can see how it cleans up across the overlaps and everything is working nicely. Simple little click, one single click. There's my punch. Then I make decisions about the punch. And again, this is another one that's touching my carrier. So let's put in these radiuses in the corner, right in there in particular. And then I'd like to also have that cookie that overlap right there where it touches against the punch in the center. And then where do we want to start it? So move down a bit. Let's punch right there at the end. Okay, so I've worked through my different punches. Those green faces I will use then when actually constructing the three-dimensional punch that's going to sit inside the die set. A few other things I'd like to do since I'm working with this expanded carrier. I want to be able to show that. This one of these things that because it's based upon a library, I've had time to look it over and check it. I know my dimensions are good, so I can reuse it with confidence. If not, if it's something new and I want to check to make sure that I'm not overstretching it and breaking it, I can run it through the analysis as well. So it's not just a dumb shape that I'm working with. So I'm going to do at this point is to make this area where it has its first expansion, and that's going to be the station I work with. And to make sure I've got everything lined up, let's bring in the form we want. Well, right here is where we made the hit and also put that stretch feature in. We got the two flanges. So I'm saying let's just do all that right there in that one station. And that's also going to pull it so that I end up opening up that expandable web. Let me bring it in again here. And this time you can see I'm using the dimensions throughout. So this one I want to edit. You can see how easy it is to do that. I'm going to be methodical about it. I want you to see what's happening. So once that is in place, see everything is lined up with all the holes and everything. And I'm going to work with a face. So grab a curve, use my indicator again, my 2D indication. We'll put a face in here, and then we want to trim out that hole that we created. Simple modeling tools. Like I said, Cimatron's been around a good long time, so it's got all kinds of tools for creating whatever you need to create. Now I'll edit the dimension, and simply I could have taken the measurement to see how much the gap is. We'll open it up by that difference, which is going to be 12 mil. So adjust the 50 mil to 62 mil. Okay. And there I've opened it up so that it shows me what that would look like. And that's important. I need to know where that metal is going to be if I'm going to do anything around that area, right? Even if I'm just going to use a lifter or my cutoff. So with that, we can start dropping in the rest of these forms. So maybe what I'll do is say, this is the form where I did my thinning. So I worked off the die side, and maybe I want to decide where I want to add that in. So that will be the cutoff. And then I can say, before we do that, let's also add that same shape again. And I'm going to be concerned about those punch holes that are remaining. The decision might be instead of punching them up at the front, I'm going to punch them here at the end because of how much that shape changes. That way I get the correct shape of the hole. And I'm stretching it. So I position those. Now we just want to copy the web on the way down. How many times do I want it to repeat? And there I've pretty much sized up what this strip is going to look like. So again, I just want to show you that you're not forced down any set path. You do what you need to do to get the information you need, and then work around that as you move forward. Okay. So there's my strip. That's something I could quote to or even begin tooling to. So you may have one guy, and we see this in a lot of shops, where the quote guy has enough tools that he can do the, engineering part of the quote. And then from there, take that information once he gets the quote, send that to the engineer now, the die designer, who's going to carry it forward here. All right, so now I'm going to bring in a die set that we built within the system here. So it's all custom. And this could be whatever you want it to be. It could be just the two shoes and the guide pins, or it could be a number of things. Like I put in some stripper plates and a number of different things that I could start with. And you'll see that when I load it. So here, this particular die set has got the coffin handles built into the plates, the shoes. And I've also got my guide bushings and my uh, pins. I've also got my gas cylinders for my stripper. And I may not have decided yet on everything, but it's enough for me to work with. And what it's done is based upon the rules that you see, it's loaded this information into setup when I brought the die set in, but it sized it according to the strip. So that's how it knows the width of the overall die and the length of it. Plus, it's also giving me my clearances, which you see here. If I want to make a change, I just come over here to my setup and say, all right, this die steel length where I've got my stripper plate, let's make that bigger. I want to maybe adjust it so that I can capture what I need for those punches. But I also have the rules in my head that know how big a plate is that I can get into my wire EDM. So I'm working with those decisions. And as I make my changes here, I might say, well, this gas cylinder, I want to relocate it. It's the cylinder I want, but where do I want to put it? So just because it's put in there for my convenience doesn't mean it's forced to be there. I can change it, right? So maybe we'll tweak that in a bit, give myself a little bit more room. And then with that, maybe I want to change my guides here. And you can see I'm working through the assembly over on the left, turning on and off the major subassemblies, right? Here I'm isolating those punches now, the green punches. And what do I want to do here? Well, I'm thinking let's take a closer look at those location holes. Let's look at, looks like I'm pretty clear. So I can start putting in my punch holders. So here's a preset assembly with all the components, and you can see it knows the dowels and the screws I'm using, and it's going to know the hole that those things need to sit in. So let's locate a couple punch holders. Those punch holders can be considered the same component, or they could be an individual component so that I have separate control over the size and the width. We'll go ahead and add those in, and what it's done is it's matched the existing height that's already there for my area above or between the stripper and the punch plate. So the rules set up here are common and can keep being used with each of these different components that I bring in. So it changed the overall size so I have enough steel around the punch. Now we'll pick these punches and say, let's go ahead and build the steel here. And now it's saying, what do I want to do as far as the components to affect? I want to put the punch in, but then cut the holes on both sides. So I have the hole it sits in the punch holder, but then I also need the hole it creates when it goes through the die steel. I need the land, I need the 2 degrees relief. I need it to open up bigger in the shoe so I can get the slug drop. And it goes back to the rules we first established. So you can see how the system just builds knowledge on top of itself that you can keep working with. If I introduce a new component into the die set, like maybe I've got a material guide that I included and the punch has to come out into the material guide area, it will see it and then ask me how much clearance do I want to put into that area where I'm cutting through the material guide. Oh, you can see it's dropped those holes in for me nicely. Side view, you can see how it built the clearance for the coil where my plate is coming down on top of it. You can see the clearances it's built for the movement of the plate going between the material guide. And then there in section, you could see the punch as it cut through all the different holes. So naturally, if there's a change, we just update those punches if I were to reorder them or if the shape were to change. Let's look at creating a form here real quick. So I'm going to bring in another little sub-assembly, and you can see it's pretty simple. We'll just position it where we want to put it in our die shoe, and then go back into our setup so that we can look at the shape and size of it. And you can see all this is set up with a pull down. You can use formulas. You can create pull down lists. You can create sizes based upon the catalog size. So if I bring in a component that I might cut the length off of, I can select the correct length I need to minimize how much I'm cutting. All right, so we've got our steel here. That's what we're going to work with. And basically I said, let's take the shape of the die side and let's bring it into the steel insert that I'm working with. So how are we going to build this? Well, let's start by maybe adding some more material right here on top, just so I have stuff to cut away basically. And I want to use the shape of this particular flange. So I'm going to cut the block, like you see here, and start picking my way down these faces. And as I pick it, you can see it's updating the cut. And it might reach a point where it says, I'm not sure what to do. But just keep picking, and you see how it's changing that top as we go along. Finally, I got that last one. There it is. So it's going to chop that back based upon the shape of that flange. Now I've got the inside of it. I need to open that up where I've got the trench, right? That groove. So I'm just going to say I want to create a chain from one side to the other. And then I'm going to direct that out into some faces, and we'll give it a respectable distance. And I'm going to say follow the slope that it's got based upon the bottom here. So I'll get to the midpoint and then go through the center point here of that hole. And that's directed it at that same sloping direction. Do a quick little operation where I stitch those together. So now I can simply use this series of faces as an open sheet solid and cut the block back based upon that. All right. Pick it as an object. And there I've got the shape of it now. So I know what faces are being formed, and then I know what my block looks like. I can start making the changes. You know, if I need to change those screw holes, I can. If there's another block around it that needs clearance, I can chop away at a safe area to give it that clearance. I mean, you get the idea. So fairly quickly, I've got that side, and then to get the punch side, I would just offset those faces into another block very similarly. So hopefully you can see that you can move through this pretty quickly, and you don't have to specifically work in any certain area. You can do what you need to do. All right, here we're getting to the end. I just wanted to show the motion analysis. Okay, so you can set this up so that you have the motion where the stripper engages the top of the punch plate, or actually the top of the coil. Here I'm advancing the coil one progression. I'm coming down, the stripper holds it in place, the punch engages, knocks the hole out. And all this can be done with full collision detection. So if there's going to be an error at any point, I can see it. So besides the FEA analysis, it also has the kinematic motions that you can use to double check your work. Okay, well, let's go back to the questions. Let's invite Joe to be back online here. If you have
Oh,
any
absolutely.
questions, feel free to ask.
Dave, you
I
did
don't.
a fantastic job. I was really amazed how you just kind of took that process and ran through it so quickly and easily. Again, this program is very much designed for the dye industry and mold industry, and And they say Dave is a senior application there at Cimatron. What I did today is recorded this video. So what I plan on doing, I know a lot of times that after the session's through, that afternoon or the next morning, I get a lot of requests. Can I get a copy of that video? Can I, and so on. So I feel that it's best, and I'm sure you saw this last week. What I plan on doing is sending out an email and sending you the link to the auto-stamped YouTube um, video area so that you're able to view this at any time. And this way, if there's any questions that today you were unable to think of but thought of, hey, let's there is questions. Maybe does it? Are we looking at will the components provide us with a bill of materials at the end? Maybe that's a great question to ask Dave, and then we can go through those questions as well. So with that said, I'm going to turn everyone on if I can figure out how to do this correctly. But and then if there's any questions, feel free to ask Dave. Let's see, this will mute everyone in the meeting. Let me try that, and then let me see, I'll unmute. Okay, so we have. Yeah, I'm not sure how to do that. In fact, Dave, if you know how to, oh, here we go. I guess you have to unmute yourselves, everybody. So if there's any questions, feel free to jump in or we looks like we'll end this session a little early today. That sounds good. We'll end this a little early today, and next week, I please welcome you back. We will have Jeannie He from Forming Simulations, and she'll be actually taking that same part that David did today, and she's going to take it and actually simulate the formability, and if the process is correct, so that they could, before you cut steel, you have a process that's will work in production with either no to very limited rework out on the shop floor. So please look forward to that next week. I'll be sending out emails a day prior to that webinar, and hope to see everyone again next week. And I want to thank everyone today for joining us. And if no questions, I think at this point we will end the session and look forward to a copy of that session being sent out to you probably as early as tomorrow morning. Thanks again, David, and thank you everyone for joining us.
Thank you.
Thank you. Bye now.